Hello friends, welcome back to the data structure tutorial, and today we will be discussing about inserting a new node at the end of the single linked list. In the previous video we have discussed about how to insert a new node at the beginning of the list, and we know that to create a new node we need a structure of a node, which I have already declared here. And suppose we have a function that inserting at the end and we are receiving the data. So whatever data you will be receiving into this function, that data has to be insert at the end of the list. So we need to create a new node, and we have also discussed that how to create a new node. If you are not aware of this code, so please check the previous video. So here we are creating a new node. Whenever you receive the data for insertion at the end, we need to create a new node whose name is temporary, and this new keyword will allocate the memory. So let's assume that the new memory location allocation is 500. The name of this new memory location is temporary. Whatever data you will be storing, suppose 55, and on the next line we done with this. The next line, the temporary's next field should be null. So temporary's next field should be null. Now here I have a mistake, that it should not be the node, it should be the next. Okay, so int information, so integer information we are storing here, and integer next, this should not be there. So next is your second field, which is null now. So what you need to do, you need to check first whether you have the existing list or not. So if you don't have any existing list, so let's say we don't have a list, so how will you know that? In the previous video also we have taken this condition. If your starting point is equals to null, if your starting point is null, it means that you do not have any list. So this temporary node itself become your starting point. So you have to write like this: your starting point address will be taken from temporary. So what is the current address of temporary? It's a 500. You have assigned to the start, so this will be your starting point. So there is only one node in your list, and that is temp, and now it is called as start. Now what if there is another case that we have a list of the elements? What if there is another case we have a list of the elements? So let's assume that this is the list which we have available with us. I'll taking some random values, and every block will have certain addresses. So I will take 700, 200 and 800. So this block will connect it to the next one, so it is pointing to the address 200, and this is pointing to the address 800. So this is a singly linked list available, and the last node will have the null point, and this is your starting address, that is 700. So now what we want to do, we want to assign this new node which we have created, it should be at the end of the list. Okay, so I'll repeat this list, that I have a 800, 200, 77, 800, then 92. Next field is null. This block having the address 700, it is pointing to this address whose address is 200, and it is pointing to the address which is 800. And this is your new node. We'll assuming that this is your new node with value 55. Next is null. This is the address of that block, and this is temporary. This newly created block I have written at the end of the list, and this is your starting point. This will be your start. Okay, so we are in the else part. It means that we want to find out the end of the list. Okay, so this is the existing list available with you, and you want to find out the end of the list, but you cannot jump directly to the address 800 because you have only starting address, that is 700. So, and how do you know that which node is the last node? So you can see that if there is a any node is a last node, the next field is containing the null value, and rest of the nodes will not contain the null value. But you cannot jump directly to that node, you have to start from here. So what we'll do, we'll start from this address, that is 700, and we'll check that whether the next field of the 700 is a null, no, then go forward. Whether the next field of 200 is null, no, go forward. Whether the 800's next field is null, yes, null, stop it. Okay, so to do that, what I'll do, I'll create another pointer p which will hold the address of start, which hold the address of start. Now start's address is 700. To whom you have given it? You have given it to the P. Okay, and what condition you want to check? You want to check whether the P's next is null or not, and if not, then you will forwarding it. Okay, so how to write this in algorithm? So we'll be writing here. So I'll quickly erase that. Okay, so here you have to write while loop, while P of next is not is equals to null. P of next is not is equals to null. If this is the case, you will be moving your P to the next location. You will be moving your P to the next location. Now P is equals to start. Starting address is given to P. While P of next is not equals to null, let us check it. What is the P of next? It is 200. 200 not equals to null. Okay, condition is true. Go get inside P of next, that is 200, copy into P. You are copying 200 into P. So what is the new address of P? It is 200. Okay, what is the current P? It is 200. So it will come back 200's next, which is not null because it contains 800. So it will come in P of next, that is 800, which will be copied into P. So current P is at 200, P of next is at 800, which is not null. So you are copying the 800 to the P. So P will be moving forward again. Now again it will check P of next, which is not null, but it is null. So here your loop will be stopped. So now what P is representing? P is representing your last node of the list, existing list. And what we want to do, we want to add this new node at the end of the list. So after P, we need to connect with the address 500. So what simply you will do here, instead of null, instead of writing this null, you will be connecting the address of temporary, that is 500. So you will be writing here 500 and automatically it will be connected to the last node, which is your newly added node, and after that there is a no node. It means that the next field is null. But when you are doing this after the loop, so P is pointing your last node after the loop. So P of next, sorry, it's a P of next is equals to temporary. So what you did, address of temporary, that is 500, you put into the P of next, that is here, and the last node is automatically added. Close your else part here and close your function here. So this is an algorithm for inserting a node at the end of the list. Now let us write a code for this. So in the previous video, we have created a function for insert at the beginning. Similarly, we need to create another function, that is void insert at end, and it will also be receiving one data, that is integer data. Okay, now whenever you are creating a new function, you have to check whether you have a class of a node, that is structure of a node. Yes, we have. Okay, then we have a create node function which will help us to create a new node. Okay, and now we are in the function called insert at the end. So here what you will be doing, you will be calling a function that is create a new node for the given data. So once you created a new node, you have to check whether the existing list are available or not. So how will you check it? Simply you will write if your start is equals to null, it means that your starting point will be your temporary. It means that you do not have any list, and whatever new node you have created, that node itself becomes a start. The same condition we have written it for the beginning also. Okay. Now in the else part, you have to copy the address of starting point, that is P equals to start. Then you have to apply the while loop to find out the last node. And how will you find out the last node? That is P of next is not is equals to null. Then you need to copy the P's next address into the P. It is showing some error to the P because we have not declared that object. So globally here I'll write one address P which should be pointing initially to the null. Okay. Now you can see that inside at the end we have written the logic for that. Now we'll see in the next video how to insert a node at the middle of the list.